Hello, welcome to the second lesson of polar equations. Today we're going to graph these polar equations without the use of a calculator. The first thing we want to graph is all of the points where r is equal to 5. So let's just start putting some points on. If I go out 1, 2, 3, 4, 5, that's going to be a point. That's going to be a point. So all of these points that I put on here so far, give or take some margin of error, are at r equals 5. So if we have all of the points where r is equal to 5, what we would create is a circle at the distance 5 away from the origin. Assume that that's a circle. That's an awful circle. But hopefully you can use your imaginations and see that that would be a circle. This next one, where pi over 3 is this line here. So to put all the points that pi is equal to 3 would be all of these points. But then if the r is negative, we would have to go back here. So to find all the points where r is equal to 3, it's just going to be a straight line in both directions. And that straight line passes through the origin. Now we get to things that are a little bit more difficult. R is equal to 2 sine of theta. Now this is a little confusing because our points we write as r theta, where r is the distance away from the pole, and theta is the angle that it makes with the pole. However, what we're putting into our equation is what typically is the second value. So we're used to putting in the first value into our equation to get our second value, and now it's in the opposite order. So if I put in 0, then I have 2 times sine of 0. Sine of 0 is 0, so that's 2 times 0, which is 0. Now let's do pi over 6. So if I erase this, 2 times sine of pi over 6. The sine of pi over 6 is 1/2. 2 times 1/2 is 1. Now if I do pi over 4, 2 times sine of pi over 4 is 2 times root 2 over 2, which is just square root of 2. Now you guys can pause this and do the rest of the problems between 0 and 2 pi and try to find the values. Now I can undo this, and you can look at all of the values. Make sure you've gotten them correct. Now let's try to graph these. If we start out with the value 0, 0, so the radius is 0 and the r is 0. That's pretty easy, right in the middle. Now we have to figure out some scale. It looks like the largest numbers on here go out to 2. So let's say maybe each of these is a quarter. So 1/2, 3/4, 1, 1.5, 2. Just so our graph isn't so small that we can barely see it. All right, so we have 0, 0, 1 at pi over 6. This is pi over 6. We go to 1, and we'll make a point. Now, if I do pi over 4, which is this next one, and the square root of 2. Now, the square root of 2 is 1.414-ish. But all we really need, we can't really tell the difference between 1.4 and 1.3 on this. So 1.5 is about right here. And so 1.4 is going to be somewhere right there. You don't have to be more accurate than that. Pi over 3 gets us to root 3. Now root 3 is 1.717, I believe, 1.732. So 1.7 is good enough. Here's 1.5. Here's 1.75. So a little bit before that will get us to that point. And pi over 2, which is straight up, will get us to the point 2. Now we come back down to 2 pi over 3 being root 3, 3 pi over 4 being root 2, and 5 pi over 6 being 1. And then at pi it's 0 again. So it starts out, comes up like this, passes through these points, comes around, and then gets back to 0. Now at 7 pi over 6, it's negative 1. So instead of going out that way to negative 1, it actually cuts back and is that same exact point. 5 pi over 4 is up, is negative root 2, so it goes back to that point. And 4 pi over 3 goes up negative root 3, which is that point. So it just repeats those same points again, and it will just follow that circle a second time. All right, so we're done with that one. Now, our graph is going to be a little bit different. 2 plus 2 cosine theta. I'll give you guys a few minutes to try to find all of the values between 0 and 2 pi. So pause the video. Here are the points that we have. The points range from 0 to 4, so we have to think of an appropriate scale. Maybe every 2. So 1, 2, 3, 4. Now at theta equals 0, so over here, the r is 4. Pi over 6 is at 2 plus 1.7, so that's 3.7. At pi over 4, it's at 2 plus root 2, so about 3.4. At pi over 3, it's at 3. Pi over 2, it's at 2. 2 pi over 3 gets it at 1. Oop, right there. 3 pi over 4. 2 minus 1.4 is about 0.6. So somewhere about there. 5 pi over 6 gives us at 2 minus 1.7, which is about 0.3. And then at pi, it goes to 0. So it starts out, comes up, and then it kind of curves around there. So now let's see what else happens. At 7 pi over 6, it's at 2 minus 1.7 again. So 2 minus 1.7 is about 0.3. At 4 pi, or 5 pi over 4, it's about 2 minus 1.4, which is about 0.6. At 4 pi over 3, it's at 1. So far it's come out there. 3 pi over 2, it's at 1, or at 2. And you can see that this is just repeating this top pattern. And so we can continue this around and come back to 4. I think that should be enough for you to try out your worksheet.